Space is an endless sea of wonders, a boundless expanse that stretches beyond our imagination. It is a realm where time and distance lose their meaning, and the mysteries of the universe unfold in a grand cosmic ballet. It's filled with galaxies, planets, and of course stars. Each galaxy is a massive collection of stars, gas, and dust, bound together by gravity. Within these galaxies, countless solar systems host planets of all kinds, some of which may even harbor life. Stars are the building blocks of galaxies, and they play a crucial role in the universe's evolution. They illuminate the cosmos, acting as beacons of light in the vast darkness of space. Their life cycles, from birth to death, shape the very fabric of the universe. They provide energy for life. Our own sun, a relatively average star, is the source of all energy on Earth. It powers the weather, drives the seasons, and sustains all living organisms. Without stars, life as we know it would not exist. Their birth is a tale of cosmic drama. Stars are born in the dense regions of nebulae, where gravity pulls gas and dust together to form a protostar. As the protostar grows, it heats up, eventually igniting nuclear fusion in its core. It's a story of gravity, gas, and light. The interplay of these forces creates the conditions necessary for star formation. Gravity pulls the gas and dust together, while the heat generated by the collapsing material causes the protostar to shine. Our journey begins within vast clouds of gas and dust. These clouds, known as nebulae, are the birthplaces of stars. They are the nurseries of the universe, where new stars are born and old stars return their material to the cosmos. These clouds are called nebulae. Nebulae come in many shapes and sizes, each with its own unique characteristics. Some are bright and colorful, while others are dark and mysterious. They are the raw material from which stars are made. They are the birthplaces of stars. Within these nebulae, regions of higher density collapse under their own gravity to form new stars. These stellar nurseries are some of the most beautiful and dynamic regions in the universe. Nebulae are like cosmic fingerprints. Each one is unique and tells a different story about the history and evolution of the universe. By studying nebulae, astronomers can learn about the processes that lead to star formation and the life cycles of stars. Each one is unique and breathtaking. The colors and patterns of nebulae are created by the interaction of light with the gas and dust. These stunning images, captured by telescopes like Hubble, reveal the beauty and complexity of the universe. They hold the raw materials needed to create a star. Hydrogen, helium, and other elements are the building blocks of stars. As these elements come together under the force of gravity, they create the conditions necessary for nuclear fusion, the process that powers stars and gives them their light. Nebulae are not just random clouds in space, they are some of the most fascinating and dynamic structures in the universe, constantly evolving and changing over time. They are dynamic and ever-changing, with their shapes and colors shifting as the gases and dust within them interact with each other and with the forces of gravity and radiation. Nebulae are composed mainly of hydrogen and helium, the two most abundant elements in the universe. These gases are the building blocks of stars and planets. These elements are the most abundant in the universe, making up about 99% of the visible matter. The vastness of space is filled with these essential ingredients for star formation. Nebulae also contain small amounts of other elements which are created in the cores of stars and spread throughout the galaxy when those stars explode as supernovae. These include carbon, oxygen, and iron, which are crucial for the formation of planets and life as we know it. The presence of these elements gives nebulae their beautiful and varied colors. The gas and dust in a nebula are spread out over vast distances, creating a diffuse and ethereal appearance. However, this material is not evenly distributed, but they are not evenly distributed. Some regions are denser than others, leading to areas of higher concentration where interesting processes can occur. Some areas are denser than others, and these denser regions are where the magic of star formation begins. The contrast between dense and less dense regions creates a dynamic environment. These denser regions play a key role in star formation. They act as seeds, where gravity begins to pull the gas and dust together, initiating the process of creating new stars. Gravity begins to pull these seeds together, causing them to collapse and heat up. Over time, this process can lead to the birth of a new star, shining brightly and adding to the beauty of the cosmos. Gravity is the architect of the universe. It shapes the cosmos, guiding the formation of galaxies, stars, and planets. Without gravity, the universe as we know it would not exist. This invisible force is responsible for the grand structures we observe in the night sky. It's a fundamental force that attracts objects with mass. Every object in the universe, from the smallest particle to the largest star, experiences this force. Gravity pulls objects towards each other, creating the intricate dance of celestial bodies. In a nebula, gravity acts on the denser regions. These regions, rich in gas and dust, become the birthplaces of stars. The denser the region, the stronger the gravitational pull, setting the stage for the creation of new stars. It pulls the gas and dust particles towards each other. Over time, these particles begin to clump together, forming larger and larger masses. This process is slow but relentless, driven by the unyielding force of gravity. As more and more material clumps together, the gravitational pull grows stronger. This increasing pull accelerates the clumping process, drawing in even more material. The growing mass becomes a gravitational magnet, attracting everything in its vicinity. This process of gravitational collapse is crucial for star formation. As the material continues to accumulate, the core of the clump becomes increasingly dense and hot. Eventually, the conditions become right for nuclear fusion to ignite, and a new star is born. As the cloud collapses, it begins to spin. This rotation is a natural consequence of the conservation of angular momentum. The initial slight rotation of the cloud becomes more pronounced as it contracts. The spin gets faster as the cloud shrinks. This is similar to how a figure skater spins faster when they pull their arms in. The conservation of angular momentum ensures that as the radius of the spinning object decreases, its rotational speed increases. This is similar to what happens when a figure skater pulls their arms in during a spin. The skater's spin speeds up, just as the collapsing cloud's rotation accelerates. This increased spin helps to flatten the cloud into a disk, where planets and other celestial bodies can eventually form. Gravity, therefore, not only creates stars but also sets the stage for the formation of entire solar systems, making it a fundamental force in the universe's ongoing evolution. The collapsing cloud of gas and dust heats up as it gets denser. This is because the particles collide more frequently. The temperature at the center of the cloud continues to rise. Eventually, the core becomes so hot that it begins to glow. At this stage, the object is no longer a nebula, but it's not yet a star. It's called a protostar. The protostar continues to gather material from the surrounding cloud. It grows in mass and temperature. Section 5. Igniting the cosmic furnace nuclear fusion. The core of a protostar is under immense pressure and heat. Temperatures reach millions of degrees Celsius. This intense heat and pressure trigger a remarkable process: nuclear fusion. Nuclear fusion is the process where atomic nuclei fuse together to form heavier elements. In the core of a protostar, hydrogen atoms fuse to form helium. This fusion process releases an enormous amount of energy. This energy is what makes a star shine. Section 6. A star's defining moment. Reaching the main sequence. The moment nuclear fusion begins, a star is born. The star enters what's called the main sequence. The main sequence is the longest and most stable period of a star's life. Our Sun is currently in its main sequence phase. A star on the main sequence is in a state of equilibrium. The outward pressure from nuclear fusion balances the inward pull of gravity. This balance is what keeps a star stable. Section 7. The lifeblood of stars: hydrogen. Hydrogen is the most abundant element in the universe. It's also the fuel that powers stars. Stars on the main sequence continuously fuse hydrogen into helium in their cores. This process releases the energy that makes them shine. The amount of hydrogen a star possesses determines its lifespan. Massive stars burn through their hydrogen fuel much faster than smaller stars. Section 8. The stellar clock: a star's lifespan. A star's lifespan is a delicate balance between gravity and nuclear fusion. Gravity wants to collapse the star. Nuclear fusion pushes outward, counteracting gravity. However, a star's hydrogen fuel is finite. Eventually, it will run out. When a star exhausts its hydrogen fuel, it begins to evolve off the main sequence. What happens next depends on the star's mass. Section 9. Beyond the main sequence: stellar evolution. Once a star runs out of hydrogen in its core, it starts fusing helium into heavier elements. This causes the star to expand and cool. It becomes a red giant. Red giants are much larger and cooler than their main sequence counterparts. Our Sun will eventually become a red giant, engulfing the inner planets, including Earth. Section 10. Star death and cosmic recycling. The fate of a star depends on its mass. Low-mass stars like our Sun will eventually shed their outer layers. This creates a beautiful expanding shell of gas called a planetary nebula. The core of the star will remain as a white dwarf. White dwarfs are incredibly dense and hot, but they slowly cool down over billions of years. Massive stars, on the other hand, end their lives in spectacular explosions called supernovae. Section 11. The enduring significance of stars. Stars are essential to the universe as we know it. They are the factories that produce heavy elements. These elements are scattered throughout space by stellar winds and supernova explosions. These elements are the building blocks of planets and life itself. We are all made of star stuff. Stars illuminate the cosmos and drive the evolution of galaxies. Their birth, life, and death are a testament to the awe-inspiring power and beauty of the universe.